99% of life vanished. The answer is not just the impact. The Chicxulub impact was a geological instant of immense fury. Ard vaporized rock and sulfur shot high into the atmosphere. A re-entry friction ignited global wildfires instantly across continents. This initial thermal pulse devastated surface-dwelling dinosaurs. But the true killer was the subsequent impact winter. Atmospheric aerosols blocked virtually all sunlight for months. The photosynthesis ceased. The base of the entire food web collapsed. Herbivores starved first, followed swiftly by the large carnivores. The oceans suffered equally, starved of solar energy. Global average temperatures plummeted drastically, inducing severe chilling. This impact winter lasted for years, a truly global frost. Now that we understand the cold, let's explore the heat. The impact vaporized massive deposits of carbonate rocks. This released enormous quantities of sequestered carbon dioxide gas. Once the suit settled, the greenhouse effect took over. Here, temperatures began a dramatic, centuries-long rise far beyond previous norms. This super greenhouse state caused significant ocean acidification. The subsequent climate was radically different, favoring smaller, adaptable life forms. Small, burrowing, endothermic animals weathered both extremes best. Their size and metabolic flexibility provided a crucial survival advantage. Ecosystem complexity vanished, replaced by simplified, robust communities. The world the dinosaurs left was dramatically different from the one they inhabited. Geological records clearly trace this rapid environmental destabilization. The climate system experienced massive radiative forcing from multiple sources. Sulfur aerosols, highly reflective, caused the initial cooling surge. But carbon dioxide then acted as a long-term thermal blanket. Paleoclimatology confirms these dual, opposing climate phases occurred. But the massive terrestrial erosion followed as vegetation cover failed. This sediment-choked waterways, further disrupting aquatic ecosystems. Survival hinged on small size, rapid reproductive cycles, and mobility. The slow regrowth of forests dictated the pace of recovery. But the atmosphere struggled for millennia to regain its prior equilibrium. Geologists examined the iridium layer as the temporal marker. These tiny glass beads are solidified evidence of the heat pulse. Survival meant finding insulated niches away from immediate surface effects. The great size of the dinosaurs became an overwhelming liability. Reptilian traits, low energy needs, offered temporary climate buffering. An aquatic environments experienced slower, but equally profound, ecological shifts. A methane release from deep-sea reserves compounded the greenhouse effect. The lack of predictable light cycles destroyed behavioral patterns. Water availability became critically scarce during the coldest periods. The sheer scale of debris dwarfs any modern planetary threat visualization. And recovery was not immediate, it was a staggered, multi-century process. And the crisis acted as a radical filter, reshaping the entire trajectory of life. The energetic pulse may have momentarily stressed the planet's magnetic shield. The widespread wildfires left a global geochemical signature in the strata. At the age of mammals dawned amidst environmental wreckage and high warmth. A life that could exploit both aquatic and marginal terrestrial niches thrived. Sulfur cycles eventually stabilized, but only after prolonged ecological damage. The warming phase was characterized by extreme, persistent heat waves. Insects with short life cycles recovered and diversified relatively quickly. Deep sea sediments record the slower, chemical consequences of the event. It was the duration of instability, not the single event, that proved fatal. Ecosystems rebuilt, but the blueprint of life fundamentally shifted. And the climate crisis restricted energy flow across the entire biosphere. The planet experienced a profound, forced evolutionary bottleneck. The impact event demonstrates climate tipping points are irreversible quickly. We study this catastrophe to comprehend Earth's fragility in deep time. The fate of giants teaches us the power of atmospheric chemistry.